Continuation on this series on air and fuel pressures, how to not diagnose them. Hopefully you've already watched the one on low pressure or fuel starvation problems, because that was the predecessor to this one. Now we're going to go into fuel rails and on the motor testing. You'll notice on this high pressure gauge that I'm showing 40 pounds of pressure on it. The air is not connected, so ignore it at this time. But I wanted to point out, this motor's been sitting here for an hour and still has 40 pounds of pressure. They won't all be that good. If it leaks down to 0 in a minute, that's okay. Some slow leakage is acceptable, but a real rapid leak, when we turn the key off, implies a problem, a fuel leak in the system. This tells me there probably is no pressure loss on the fuel side. Now, during this sequence, I'm going to put some bad diaphragms in and show you what you'll see with the failed diaphragm and how we would go about diagnosing it. So anyway, you notice this is 40 psi and held steady, and you'll also notice when I turn the key on, it barely moves. Okay, also notice this low pressure gauge. I'll explain the differences. Okay, see how it jumps up and then it drops down. And notice that it drops down about 15 psi. This pressure reading is being taken from the BST over here at the low pressure port I discussed in a previous video. So it's only seeing the pressure from the low pressure pump, which resides right here horizontally. This line here returns fuel pressure from the fuel rail to the high pressure pump, excess fuel. But we want to know what the low pressure is doing. For the reasons of maybe you're running wide open and you see your high side pressure gauge fall down a little bit, you look at your low pressure and take note what these two pressure gauges mainly do here. We already know what this one's going to do. It's going to react the same way it just did. So here goes the startup. Now notice this went up to 90, okay, and it's holding. Now do it yourself quick check. I didn't hook this gauge up for this very reason. This is a low pressure where you connect it. If you push this in, hear the air escape, watch what the fuel pressure did. Went down to 15 psi. That's the pressure on the low side. Okay, the high pressure is totally dependent on low side pressure. So if you lose air pressure, you're gonna lose fuel pressure. It's important to understand that. Now, let's hook this gauge back up. Don't keep in mind what I'm doing. I've plugged that hole down there, and I actually have water hooked up to the flush port here. When I do run it, it will supply the motor, and it can't escape out the bottom because I capped that line. See, pressure goes up, but it doesn't go real high up before it falls off. Now that had low pressure and high pressure pump running. That's why it went up to 40 psi and then fell off rapidly, because there's no air. Now let's start it and watch what happens. 90 pounds of fuel pressure and 80 pounds of air pressure. Perfect. Now we turn off the motor, and as the air slowly leaks down, and it should be slow, this one's better than most. The leak down rate, you notice it's coming down quite slowly. You'll notice fuel pressure is approximately 10 pounds higher, which is correct for OPTIMAX motor. On a Pro XS motor, that would be 14.7 pounds different. But you'll see the fuel will follow the air down. There's no appreciable air leak in the system. This is better than average because the fall rate's very slow. Same thing down here. This kind of becomes irrelevant because I don't have a problem between these two. So this low pressure one is not an issue. We know it's okay. We're only concerned about that if we think we have a starvation problem, and we can prove it with this gauge while running the boat on the water. If we see this falling down, if this one's falling down, we know we have a low pressure side problem. But it could also affect the high side, so you don't want to lose that. Okay, we're back on it. This has been setting a few minutes, and notice the pressure, fuel pressure and air pressure are equal. Now, I want you to take note when I start it up. Engine smoke, idle speed, and how these gauge readings correspond. 90 pounds of fuel. Now, a shutdown. Notice the fuel pressure leaking down. It's creeping down slow. Air is holding rock solid at 80 pounds. Ideally, fuel would, that's almost considered acceptable, but I'll tell you right now it's not. We're going to hit pressure, build the pressure back up again. And it's not going to full 90, a key on, even though air is locked but solid at 80. Now we're only 9 pound spread. Now we're going to start it again. Yeah, sometimes things do not cooperate. But what we were getting was a very, very fast idle speed at times. Very fast idle. And a lot of smoke on startup, which indicates that you have fuel in the air side causing the high idle speed. This continuing to leak down, I don't like that. See, air is 80.5 pounds. Fuel is now down to what? 86. And it's steadily leaking down. Now we're going to show you the reason on it. All right, it's been setting a little bit. Pressures have dropped down, air's down a little bit. Fuel was leaking down faster. We're going to start it now. 80 pounds of air, 90 pounds of fuel. Key off. Now watch the gauges. And I want to see the leak down rates in comparison to the air. You see, we're still holding 80.5 pounds of air, and we're now dropped 2 pounds of pressure. Initial thought that there's not a serious problem, but there is a problem, and then the thing's more serious than you realize. And at times, it's bad enough that we're blowing a whole lot of smoke and extremely fast idle speed sometimes. Okay, see, it's continuing to drop though slowly. Okay, now we're going to pull it down. First, we're going to bleed the air pressure off. Notice a little fuel. When I did that, I had a spurt of fuel. You get any fuel blowing out of there, you know it like from the high side into the air system. That was a lot of fuel that picked up in the hoses from this problem. Now, I want to bleed the fuel pressure down as well. We're going to pop the fuel rails off, and we're going to show you what the problem is here. As we showed earlier, I've already taken these lines off. This is a fuel pressure regulator cover that I'm removing right now. Don't do this on air diaphragm, but on fuel pressure you can hold the cover down when you take the last screw out. Okay guys, see the hole in the diaphragm right there? And look at that big long split there. That was letting fuel come from the fuel side, get onto the air side. Occasionally you get a lot more fuel, you'd have a very fast idle speed and lots of smoke. Okay, we replaced that fuel diaphragm and corrected that problem, but now we're going to show you a different problem and go through the steps to look at it. So, fuel pressure jumps right up, okay, but we got no air pressure, so it's not going to go up to 90 pounds until we start it. Okay, we're about 2 pounds low in air pressure. We're also 2 pounds low in fuel pressure. We kill it. Both gauges are slammed down. Fuel pressure is following the air pressure down. very rapidly. Now, this won't go below probably 15 pounds because of that pressure spread between the two diaphragms. It's still going to maintain what's in the low side. It won't lose that. It will only lose that spread between low pressure and high pressure, and that went away very rapidly. Now, let's stop for just a minute here. And we want to connect. We think we may have an air pressure problem. So, I'm going to put shop air on here, on the air side. Okay, and I'm going to dial it in. Oh, what's that noise? Hear it?
Sounds like it's leaking.
It is leaking. Right? These are vent holes right here. That's where air pressure is going. Okay? So, this can cause a rough idle, unstable idle, stalling, dying. End up with high pressure low because the air pressure is down too. So, we got a leak like that, we got to get it resolved and stop that leak. Now, one other thing that can be done, I need to grab a test tool for this that I didn't bring over here. So I'm going to take the mic off and leave it here and grab a pair of pinch-off pliers. And what we're going to do is this line right here dumps the excess air pressure. So the pressure regulator controls that, and the excess air goes out this down to here. With the motor running, if I pinch this line off, remember air pressure should have been 80 pounds, it should immediately jump up to over 100 pounds. So we're going to fire it up and perform that test. You may not be able to hear me. That's it. Okay, watch the air pressure. Pinched it all the way off. I barely moved, right? That's because of that massive air leak. It should have jumped well over 100, up around 110, 150 psi with that hose been soft. Okay, I think we got it. I'm sure you followed that.
Couldn't hear anything.
I think there's a show you followed that though.
What? I know. I didn't see what happened.
You didn't watch the pressure gauge?
I watched it on here. It didn't go up at all. It didn't move.
Exactly.
Yeah.
Exactly. That's my whole point.
Yeah. I mean.
It should have jumped up over 110 psi when I pinched it off.
Oh, since when you pinched that back hose, I see
when
what
I
you're saying.
pinched off the air regulation hose, the control over pressure.
Yeah.
It should have greatly exceeded the specification of 80 pounds. It should have went to like 110 to 115 pounds instantly. It did not do that. But you've already seen the regulators leaking now. But what we did for show and tell is we took that bad fuel pressure regulator and we put it into the air control side. So same diaphragm, we just put it in the other location to show the difference in how that diaphragm affects fuel versus air.
So can you point out, so this one on the top, so this one on the top is for air pressure, correct?
Yeah, correct. The bottom one is fuel pressure. This one's air pressure.
Yeah, the bottom one is fuel pressure.
Okay, this one over here. See this cover right here I got my finger on? That's a tracker valve. Think of that as a balancing device It sees the pulses from the compressor, which is a pulsating pressure, and by moving a diaphragm in there, it helps stabilize pressure spikes in the high side caused by pressure spikes in the low side, so that you have a nice, consistent, steady flow of 90 psi. It doesn't control the pressure; it controls the balance.
So commonly, which ones fail more often?
Kind of a toss-up. I really think I see more fuel pressure and air regulators go bad than tracker valves, but it's probably actually pretty close percentage-wise of which ones fail.
And then what are some symptoms that you're going to see if you have a bad air or
Well, you just saw air and you saw fuel separately.
Yeah.
Tracker valve's going to affect the way the engine runs and idles, almost identical to what the fuel pressure regulator does. That's why we have a set of gauges to narrow it down to where the most probable leak area is. These gauges are critical.
what if you didn't have the gauges? Would you have a rough idle? It'd be hard to tell, huh?
It's very hard to tell, to be accurate. But as I showed earlier, if you press the air relief valve, you use fuel out of here, you know you have a fuel leak into the air system, and it has to be fuel pressure regulator or tracker valve, or an injector O-ring that's leaking. So it's our job as technician to find out where that leaking is coming from. So simulated pressure can do that. You see how you can put air pressure in and turn the key on, cycle the pressures, and you see what things are doing without the motor running. You can actually hear an audible air leak. If you've got an air leak, you're going to hear it when you connect shop air to it. And you go around and inspect everything. You'll find that air leak in the fastest manner with engine off and shop air plumbing into the air rails. So all you got to do is get air connected to this with a paint gun regulator to regulate the air pressure. This system is designed for 80, so I usually set it at 76, 78 pounds below the regulation point to test for air leaks.
Okay. I'm stopping recording.